Swayam Prabha. Digital India. Educated India.
Good morning, everybody. We are entering into lecture number 11 on a very popular pump called liquid ring pump. This is not a high vacuum pump or ultra high vacuum pump, rather it is a medium vacuum pump, but it is very friendly pump particularly for food processing applications, chemical applications, pharma applications, paper drying applications. Variety of applications are there in typical process industries, where we are mostly dealing with wet loads or relatively large quantities of loads. So, liquid ring pump, as the name itself suggests, it is a pump based on a ring of liquid, that we will see as we proceed. So, right now the concept that I am going to cover in brief, because this is a very elaborate descriptions will be there in literature, you can go through it, lots of animations are there. This is a very good old pump which is being routinely used in several process industries. So, but because of lack of time, we will try to introduce this pump. Then we will also explain various constructional aspects of this liquid ring pump. We will also see the physical principles based on which the liquid ring pump works, and some limitations, comparisons with other pumps, etc. Finally, we will see the uses, advantages and limitations with respect to process applications, where exactly we can possibly think of using this compared to some other pumps. It is as popular as rotary pump, and it also starts from atmosphere. It can be staged also by 2 stages. It will also help some other pumps like a backing pump. So, we will see all those things little bit in detail later. First, we will try to understand the constructional aspect and working principles. Before that, I will try to give you a small introduction. The picture shows a typical commercial version, which is being produced by several companies in India and abroad. As I told you in other pumps also, depending on the quality and style, and also the materials that you are using, etc., cost varies. They are basically used to evacuate condensable vapors. That means, the loads are sort of wet loads. It can also be used for dry air also, but there are other pumps for same purpose. So, you will have to see the economics and also convenience and level of vacuum, etc. If you want 1 tar, 0.1 tar, then this pump is not going to be useful, but 20 tar, 40 tar, 50 tar, 100 tar, these are quite competitive with other pumps. They are all regularly being used in various process industries like filtration, drying operations, in a very large scale industrial operations, not a very fine scale in a laboratory, very large scale, like condenser exhausting in electrical plants, distillations, drying chambers, both in physical form, mostly for evacuating even suspended particles, not necessarily only air molecules. So, there are special features associated with liquid ring. In addition to evacuation, it can handle wet loads, it can handle particulate loads also, which rotary pump cannot handle. If there is a dust coming inside, then immediately rotary pump gets into trouble. Some chemical vapors coming into pump, you are in trouble. Okay? Whereas watering pump can handle some sort of chemical vapors. It also can handle particulates, etc. And a typical single stage pump will produce a vacuum level of the order of 100 torr. Two stage pump connected to the same shaft, of course, like a rotary pump, can produce even 20 torr, 25 torr. Why? Because you are using some liquids for the pumping action. The vapor pressure of the liquid will finally settle the issue, because you cannot get better vacuum than the vapor pressure of the liquid, which is going to do the role of a expanding chamber, compressing chamber or sweeping chamber, etc. That is the reason you can use different oils if you want to get different levels of vacuum, but most popular pump is water ring pump. That means there are other liquids like oil ring pumps, but very popular in the industry, particularly in food processing, are water ring pumps. And they are available in very huge capacity, not like rotary pumps which are 10 meter cube like that. This can go up to hundreds of meter cube, even up to 6,000 meter cube per hour. Such pumps are available. Size will be more and more. And the liquid that you are using is also called here a sealant, in addition to cooling duty, but main duty is sealant. In rotary pump, oil is acting like a sort of sealant, but more of lubricant purpose and coolant purpose also. Whereas here is a sealant purpose is the main thing. Then comes coolant, then little bit of washing effects are there. You cannot talk of lubricant effects here, okay? Because there is not much of frictional heat produced with metal to metal type of thing. We will see when we see the constructional aspect of it. Very popular liquids that normally people use in pumping liquids are water, glycol, mineral oils and organic sealants. Depending on the situation, you have to decide which liquid to be used. Its vapor pressure you have to take into consideration, its viscosity and its boiling point, etc. Because you have to take care of several issues like cavitation and even the power of the motor, because it is going to push water column. It is not like a gas type of thing. So, little bit of more thrust is required. So, the motor power requirement is also little high. So, there are a lot of scope to improve the design more and more by using different liquids, by using different mechanisms. It is up to the imagination of a typical mechanical engineer. Okay? And it is also an expansion compression type of pump like a rotary pump. But there is no metal to metal contact. This is what you have to understand. And they not only evacuate a chamber or a process load from atmosphere to 30-40 torr, they can also be used as backing pumps to some other pump which can produce 1 torr, 0.1 torr like that. And they are relatively simple pumps. Maintenance is somewhat easy and noise levels of course will be there, but with silencers etc. you can take care of that. And recirculation of same water you can use it. And if there is a huge amount of dust or something, you can filter it in some other loop. So, you can take care of things with your day to day experiences in our life. It is not like a very high tech pump. As I told you, any pump if you want to understand, first try to look at the constructional aspect of it. if you observe the figure, you have a stator type of chamber, okay, and in that a multiple vein type of structure, we can call it as impeller, is there, which is eccentrically situated in this chamber. You can feel somewhat similar issue in rotary vein pump. There also eccentricity helps to produce increasing volumes, decreasing volumes, thereby getting suction and compression, etc. And these black looking things are inlet and exhaust valves, which are coupled in this direction to that annular space, which is a increasing space or decreasing space. There will be inlet and outlet connected to the body. So, there will be suction inlet and there will be exhaust discharge. Exhaust is usually to atmosphere, or if you want to use 2 stages, suction of another watering pump. And suction is connected to the load. If you want to maintain a constant pressure against load, that is one process, or else you just want to evacuate to a good vacuum level, that is another application. But most of the time this is used in process applications to handle huge loads to maintain fairly good vacuum. That means, it is not like a pump down thing we are interested, we are more interested in Q is equal to S into P. That means, throughput has to be maintained continuously against a pumping speed to maintain a constant pressure required for a process. This is what we have discussed in the basic concepts, you remember. Q is equal to S into P, which is a very important equation in vacuum technology. There are only 5-6 equations in vacuum technology. If you remember, you can do a lot of design. Other things are like a typical mechanical things, stress calculations and heat transfer calculations, etc. Okay. So, this liquid ring is getting formed during the rotation of this impeller because of centrifugal forces. When you start rotating this eccentrically situated impeller having multiple vein type of structures, the water which is initially kept inside the chamber, maybe half filled or 3/4, it will be automatically forming a ring because of centrifugal forces. And if you carefully observe the volume between 2 veins, that means there are different chambers, sub chambers here, and that chamber volumes are decreasing this side, chamber volumes are increasing. These black looking things are basically only ports through which air is being sucked, and here it is being exhausted. There will be some spring loaded mechanisms. There are several other mechanisms which are innovatively employed to get this inlet and outlet valves. We will not go into very much detail of all those things. These are standard products now. So, it contains a shaft with an impeller with multiple veins, and it rotates in an eccentric fashion in another cylinder, and when it rotates, a liquid ring is formed, and that way increasing volume is connected to the suction side and decreasing volume is connected to the discharge side through a suitable inlet and outlet ports. So, this is the basis of constructional aspects of it. The clearances between metal surfaces are large compared to other mechanical pumps. That is very advantage for us. This allows pumps to handle small amount of solid particles, because process in chemical industries and pharmaceutical industries is not always only gas load or vapor load. There may be particulates, you cannot avoid it. So, if they are not abrasive, then you can handle some particulate load also in addition to gas load. And liquid ring also acts like absorbing the heat of compression and heat due to friction, if any. It also acts as a condenser for condensable vapors at that local temperature, when pump is working. So, there are multiple advantages with respect to liquid ring pump. Let us see the working principle little bit more in detail. You can observe right side sort of animation, and on top side there is a suction port, and this side is the exhaust port to the atmosphere. The suction port is connected to the chamber or a process application, continuously vapors are coming, then it is called loading. Okay. So, there are 3 stages. One is intake, sometimes it is called induction or suction, then sweeping and compression, they go ahead in a sequence. At the end, pressure will be slightly more than atmospheric pressure, and it opens a spring loaded valves, so that it just pops off that gas in strokes. Okay. These valves are not permanently opened valves, they are connected with some spring loading. Only when pressure is more than a atmosphere, that valve opens. Similarly, in the suction side, when the pressure is less than atmosphere, this opens, inlet valve. In both the conditions, there are certain spring loaded inlet and exhaust valves. Okay. So, intake here you can have this coupling into these chambers through another chamber. Several mechanisms are there, and very popular mechanism is this sort of cone, through which there will be inlet opening and there will be exhaust opening, and that means the inlet port is finally connected through the interior body and comes here to the central portion, into which there is a shaft, of course, and the molecules are coming out through a small opening here in this cone structure. When they are entering, why they are entering? Because the chamber volume is increasing this side, increasing volume for the same amount of number of moles, pressure decreases. Because of that, more and more molecules will be sucked into various chambers. You can see that here. The molecules are automatically sucked through this wall into this increasing volume. Look at this animation. And after some time, when it comes to this portion, inlet is isolated now. Afterwards, for some rotation, it is sort of constant volume. Afterwards, towards the end of that stroke, you will start getting a reduction in the volume, and it will reach a place where the pressure will be more than atmosphere, and it will exhaust it to the atmosphere, and that is discharge stroke. In between intake and discharge, a compression is going on. So, this is the intake. In the compression, what happens? When the impeller starts rotating in a water ring, this blue color thing is a water ring, and this ring is isolating this impeller from the body pneumatically, and at every portion the tip is touching the water ring. Okay. And here if you see, the volume is receding towards the ring, and here volume is going towards the axis. That is why volume is decreasing this side, volume is increasing this side. You can see here receding volume, and here it is going inside. So, volumes are decreasing here, volumes are increasing. PV constant. As you start decreasing more and more, pressure will be increasing. It is as simple as that. For a typical engineering graduate, I do not have to explain in detail, but my aim is to explain even to a school boy. That is why I am going little more in detail again and again, though it looks very silly sometimes. Because this machine is very important for various process applications. So, you have to take care of various things during the maintenance aspect of it as an engineer. So, each chamber rotates past the inlet port. It is creating isolated volumes of air or gas around it, around this portion, and after some time gas is getting compressed because the liquid ring converges with the cone structure here, thereby volume is getting continuously progressively getting reduced. This compression keeps on going till the exhaust valve is opened or exhaust process starts. That is called discharge. When each chamber rotates to the discharge port opening, the compressed air or gas finally it escapes into discharge because of pressure difference. It is a natural process. We do not have to take care. There are no walls, okay. There are no metallic touch points. That is the advantage here compared to watering pump or piston pump that we have discussed. The main advantage is a simple smooth watering pump is acting like a piston and cylinder, that, okay. Rather the rotor chamber which is receding and proceeding, that is acting like a piston, and the liquid ring, okay, which is acting like a cylinder. That cylinder is in turn situated in a located in another metallic chamber, but for us the watering inner surface itself is a cylinder. So, this acts like a cylinder and the impeller volumes act like a piston type, equivalent way, that way. So, intake, compressor, discharge, if you understand at various stages, you get a feel of it, and I am sure from that animation you are able to understand. This is my inlet valve, and this small opening here is the exhaust port. So, it is collecting the gases from the inlet port, sweeping, compressing and exhausting through this port, it goes out. So, vacuum starts improving till the pressure here is of the order of vapor pressure of this liquid that we are going to use. You cannot get better than that. Naturally, you can use other liquids if you want to have better vacuum, but again if it is some other oil, if it is not water, some processes will say no, we do not want oil contamination. It is a food processing application. We require 20 tar, okay. It will be better if you can produce 10 tar, but we cannot use some other liquid which is not compatible with our product. Then there are of course compromises like using mineral oils and other things, and there are certain processes where the loads may not be that sensitive to the chemical composition or whatever impurity effects that liquid ring itself will contribute, then you can use other rings. And if the vapor pressure of that liquid at that temperature is less, you will get better vacuum. So, that is why it is popularly known as liquid ring pump, but most of the time in industries you will find water ring pump, and it can be easily used as a backing pump to a steam jet ejector to get the required vacuum for your process anyway. That is how it has become very popular as a backing pump to the steam jet ejector. It is also quite popular in some applications where 100 tar is good enough. Okay. So, after getting a feel of this watering pump, its capability to produce 30-40 tar using simple mechanism of watering without any friction much, without any mechanical contact between two solid materials, and very simple inexpensive water. So, working fluid is very cheap. So, that way the cost of this watering pump is not much, and repairing is also quite easy. That is the reason they are used in several apparently little rough processes, because they are a little higher pressure in from vacuum point of view, but they are very important processes in industry like paper industry. They are used for dewatering the paper web after making the paper. They are also used in coal washeries, mineral beneficient plants. I do not know much about this word, but these are very mundane applications in day to day life. Okay. And filtering plants. Filtration, I told you in the beginning, pressure drop across the filter paper. If you create, more force will be created. So, 100 torr is good enough. One side 760 torr, other side 100 torr, good enough force will come. So, heavy industries, you can use it for filtration applications. In power plants, for example, those electrical engineers will be knowing, in power plants also the turbine condenser applications, people try to use these type of plants. Okay. And also conveying the fly ash, people use these plants. Similarly, in chemical plants for boiling and connecting liquids under reduced pressures in distillation industries, etc., these pumps are routinely being used. Even in shipbuilding and textile industries, wherever drying is involved, that means removal of moisture is involved, that moisture will be sucked under reduced pressure because boiling point has come down, and it comes into this pump and mixes with this water again. So, water vapor is removed from the load and it is mixing with water only. So, everything is friendly. That is the advantage of watering pump. Similarly, in surface condensers for removal of non-condensable gases and vapors in various applications, they are being used. So, I again repeat, the advantages of this watering pump are, they are simple, ease of operation, minimum maintenance, low cost, compatible to various liquids, whether it is pharmaceutical application or chemical application, and they have got some washing effects. They can also withstand particulate contamination, and they will produce fairly reasonable vacuum of the order of 30 to 40 torr, limited mainly by the vapor pressure of that, and they can nicely be used as a backing pumps to the other medium pumps, which can produce 1 torr type of things for some other special applications. But these are not at all used in other industries like semiconductor applications or high vacuum applications and all. You cannot employ these pumps. These are mostly used in maximum up to 1 torr type of applications in connection with steam jet ejectors or booster pumps, etc. These are typical chemical, pharmaceutical, food processing applications or paper drying applications. And limitations are, they have vacuum limitation, as I already told you. You cannot produce better vacuum than the vapor pressure. And high energy consumption, because you are trying to push water to create a ring. There is a lot of friction, there is a lot of pumping power requirement or the energy requirement to push this to form a water ring. Naturally, motor will be little high power motor, unlike turbo pumps or roots blowers. They look big, but their motor powers are not much, whereas rotary pump motor power is little high, and water ring pump, it is still more high. Okay? So, you have to think of all these things when to use these pumps. Whatever is the energy you have, energy, acceptable energy or chemical compatibility, or water is allowed at all. Some applications water vapor is not at all allowed. Such applications you cannot use this. So, you have to take a judicious decision when to use these watering pumps. Okay. So, with this idea of watering pump, let us go into little next level, where these are how these are used as backing pumps to the steam jet ejectors. That we will see in the next lecture, where we will explain you steam jet ejectors. We will introduce the working principles of it, and we will also come back to this concept of how to utilize watering pump as a backing pump to the steam jet ejector. Thank you very much.